So now, interesting enough, Google is not only using that paradigm of MapReduce, but they're also using the semantic network, the parallel search algorithms on semantic networks, and also they're real pioneer in using the neural networks as for trained learning. But that's maybe the most interesting story, because that was something that people had been trying to do really since the days of analog computers. And it was well understood what the training algorithms were. And it was well understood that you needed multi-layer networks, and Marvin Minsky proved that you couldn't do much with one-layer networks, so you would need more layers, but the training took much longer. And there were a bunch of people around, like Jeff Hinton, that kept working on it and thinking about how you would train them and so on. But the computational power just wasn't there. And it turns out it wasn't even there with the connection machine. They tried it with the connection machine, and we made some progress. And thinking machines used to have demos where we'd recognize, if you remember, like a hammer and a pair of pliers and stuff like that. But it was pretty crude. And then what happened was eventually, the big parallel computers became available through the cloud. And finally people could get, and also through big piles of graphics processors, which are basically little connection machines.
Right, NVIDIA's GPUs.
And like the NVIDIA things and so on. And so that became possible to really run these much, much bigger, literally thousands of times faster than we could do on the biggest connection machines. And it turns out when they ran those on the data, and the data was much more available then, the algorithms worked. And so all the things that we used to talk about, like recognizing faces and telling cats from dogs and so on, basically are now known how to do using neural networks. So the pattern recognition piece of intelligence, I think, is kind of a solved problem if you have a big enough computer. I don't think that's the only thing that there is to intelligence, though.
So what are the other things?
Progress, but and for instance, on the symbolic side, there's also big progress. So looking through big semantic nets, the knowledge network. So when you do a Google search now, it actually does two searches. It still does the old keyword search, but it now uses this, the semantics of it, the actual meaning of things. And so,
but the semantics network is trained through neural networks, isn't it?
It has changed what?
The semantic networks. The semantic networks had to be trained through neural networks in order to.
Well, no, that's actually not true. Those are really two different things and two different sorts of code. So one of them is happening at the level of symbolic processing. The other is much more, it's almost pseudo-analog processing. So, it's clear that there's lots of different kinds of intelligence, but roughly speaking, there's one kind of intelligence that corresponds to very fast kind of recognition, intuition, where you have lots of weak data, you integrate it, you come to a conclusion. And and so that's really what neural networks do very well. They combine a lot of weak data together. And then there's a completely different kind, which is much more reasoning, which is you have chains of facts and symbols, and that's much more what we do when we do explicit conscious reasoning about things. And the semantic networks lend themselves more to that. So they're really symbolic processing. So both of those things, it turns out, use parallel computers very well.
Yeah,
and those have made some real progress lately, although the neural networks are the ones that have, I would say, made the biggest jump recently.